without these, the following mathematicians, none of us will be here. Yes, they are the spirit for us. They are the guide and God for us. So the 9 mathematicians, which I am willing to share, just follows. So the first, Aryabhatta, he is the first one to calculate the number of days in a year. So if wasn't Aryabhatta, then we wouldn't have seen a number called 0. So he's a mathematician's astronomer from the classical era of Indian mathematics and astronomy. And he is one of the greatest Indian mathematicians. He is the first one to say that Earth is spherical and it revolves around the sun.
Ma'am,
And
are you sharing the second slide, ma'am?
no, ma'am, still I'm in the first slide.
Oh, okay. Yeah, ma'am. Yes,
Okay.
thank you.
Okay. So he is the one who found the value of pi up to 4 decimal places. And apart from that, he gave the formula of a plus b the whole square. Yes, which we all are very familiar with. A square plus b square plus 2ab. Next comes Brahmagupta. He is the first one to prove the concept of zero in mathematics. And he is the one who invented the Fibonacci identity and the sine table, which is based on the Pythagoras theorem. And he gave the Pythagorean triplets also. He was the first one to give. And the most significant contribution was the zero, of the fact that it has nothing, it has no value. And in the 7th century, Brahmagupta discovered the first general formula for solving quadratic equations. And next is Bhaskara. He's born in Bijapur in Karnataka. He was an Indian mathematician and an astronomer, and he's famous for his work in calculus and the astronomical problems and computations. He's popular for that. Then comes, yes, not only that, he's expert in arithmetic, algebra, and the mathematics of a planet related to space.
Yes, now you can teach.
Okay.
Okay.
So as I introduced Aryabhatta, he was the first one to calculate the number of days in a year. Is my voice not feeble, right, ma'am? Am I?
Now it's right. Now it's right.
Okay.
Earlier it was little
Okay.
feeble.
So he was one of the great Indian mathematicians, astronomer from the classical era of Indian mathematics and astronomy. So he was the first one to say that the earth is spherical. And actually people were thinking that it was flat. And so he was the first one to propose that earth is spherical and that revolves around the sun. And he introduced the value of pi up to 4 decimal places. Then Brahmagupta, he was the one to invent the Fibonacci series, that is the identity. And he also gave the Pythagorean triplets to the world. And he's the one who proved the concept of zero in mathematics. And he also discovered the first general formula for solving the quadratic equations. Bhaskara, he is from Karnataka, born in Bijapur. He was an Indian mathematician and an astronomer. He was famous for his work in calculus and applied astronomical problems and computations. That made him very popular. And not only calculus, he was an expert in arithmetic, algebra, and mathematics of planets. Then Hemachandra, the first version of the famous Fibonacci sequence. He was a Jain philosopher, scholar, and a great mathematician. So this is how the Fibonacci series goes. And he's a special person by his generation. And he was so called as Kalikala Sarvajana, which means that he's all knowing of the Kali Yuga. And next comes my favorite mathematician, Srinivas Ramanujam. and he was born in a small village of Tanjore district. And though he failed as he failed in English, like he stopped his studies, but still he continued his work in mathematics, and he proved himself such a great mathematician. And as math teachers, I hope you all know about his history, right? So he was the yes, he was the first one. Like he's very good in finding dividing the number in two or more squares or cube for any number. He's so expert in that. And this number is even called as Ramanujam's number 1729. So when Mr. Littlewood, he came to see Ramanujam, he saw the number plate that read as 1729. So immediately he was able to say that it's a cube of two numbers, that is it's 9 cube plus 10 cube as well as 1 cube plus 12 cube. So, and he showed that any big number can be written as a sum of not more than 4 prime numbers. Then Bhaskaracharya, see, they are great mathematicians. Just I can share about, I'm like we are nothing in front of them to talk about, but still we can share about him, about these great personalities. He has written a lot about zeros, surds, permutations, and combinations. And he wrote the 100th part of the circumference of the circle, which is straight. So our Earth is a big sphere, and that's why it appears to be flat. So apart from this also, they gave so many. And of course, being in India, everyone should know about Shakuntala Devi. Most of you would have seen her movie also. Shakuntala Devi, yes, she competed against the computer. And she was the first one to give the cube root of such a big number. And she competed with the computer and she won also. So famous female Indian mathematician known as the human computer. Her speed and accuracy, like its mental calculation, like it was unbelievable. She was so good in mental calculations. Even she could multiply numbers up to 26 digit. And finally, C.P. Ramanujam. He is born in Chennai in the year 1938. Sorry. Okay. During his doctoral examination at Tata Institute of Fundamental Research in 1957, he impressed everyone, all his fellow students and the teachers by his capability of problem solving skills. He was so good. He impressed everyone around him, and he contributed a lot towards the field of mathematics, especially in geometry and algebra. And not only that, in 1973, Ramanujam was elected as the fellow of the Indian Academy of Sciences. Yes, Mahalo Nobis. He discovered the divergence based on statistics, and absolutely, to be frank, I don't have any idea about this. So, Indian scientist and applied statistician, one of the members of the first planning commission of Free India. And he founded the Indian Statistical Institute. He also came up with studies in anthropometry in India. So thank you that I had an opportunity to talk about these great personalities. With this, I end the introduction about the great mathematicians. So it's time for us to get into the subject. I hope I shared the material. Just today morning, I was able to share it. Am I sharing?
Yes, ma'am.
Yes.
Yes, sir.
Slideshow.
I haven't started my slideshow. Namaste and good morning. So today's topic that we are going to see is how we are going to enable students to explore mathematics. Exploring mathematics means what are we actually going to do? It's like exploring means discovering, like what they themselves, how we are going to make the students to explore mathematics. Like we are just going to help the students to explore the subject. And before we could start, let us keep our mind active. So how can we keep our mind active? How is it possible to keep the mind active? How do you keep your mobile active? By charging it often, right? Similarly, how we are going to keep our mind active? By thinking. That's the way we can keep our mind active, right? So let us think for a few minutes. Then we'll get into the listening session, okay? So to start with, of course, a riddle is one of the good mode by which we can make our mind think. I just want answers from the teachers who are present here. Like you can answer. What is
87. 87.
good, good.
87.
Nice.
87.
87. Because when you turn it upside down, it goes like 86, 87, 88, 89, 90, 91. Good. Now here comes the next question. Which three numbers have the same answer when they are added or multiplied together?
1, 2, 3.
Excellent, excellent. Very good. 1, 2, 3. Yes. When you add or multiply, your answer is 6. Yes. Good. Next question. Using only, it's not an addition.
In progress.
Using only addition. This, it's not an addition. Excuse this. Using only addition, how do you add 8 8s and get number 1000?
I think
88, 888, 888.
then 3 8s.
888 and
88.
88, then 888.
yes.
1 888, then 88, then 888.
Yes. Exactly. 888 plus 88 plus 8 plus 8 plus 8 will give you 1000. Excellent. So I believe that y'all are active now and your mind is active. Yes. Okay, fine. Now comes the most important two terms by which we can make our students explore in the subject. That is explore in mathematics. So how are we going to do that? By two questions. What are they? What do you notice and what do you wonder? What do you notice? What do you mean by what do you notice? Means what do you observe? If a certain scenario is given or a problem is given, so we should make the students to observe what is absolutely there. Just observe. We don't want them to do anything. Just observe what is there. Then next comes, what do you wonder? What do you wonder means thinking. What do you think? After observing, your mind will automatically, it will get into some thinking process, right? So what do you think? The first thing is observe. The next thing, wonder. That is, you have to think. So by this, we help our students to see the problem in a big picture. A big picture doesn't make the straight sense that is showing in a big screen. That it gives a better vision of the problem, better vision about the scenario. That is what is called as big picture. So yes, now when we make the students to do this, so what have we made them to do? First, they are observing. Once they have observed, now they are into the thinking process. So once they begin to think, what happens actually? Now the students, they turn into an active doers of mathematics. They involve themselves in doing the mathematics. Now they have started to think. Yes, now the process is turning into some sensible, right? The normal students who were in the class, now they have become the curious students. Why they have turned into curious students? Because they are in the process of thinking, right? So now the normal class, it has turned into a curious classroom, right? That makes sense, right? It has turned into a sensible classroom where there is a flow of thoughts. When students start to observe and think absolutely what happens, the process that happens. Now we have changed the normal classroom into a curious classroom where there is a flow of thoughts, right? Okay, now we have made the students to observe and think. So by observing and thinking, what happens? Automatically their self-confidence develops, right? And the reflective skills also rises up. So reflective skills means what? We study something and we improve on the same. For example, if you have attended an interview, so you have made some mistake. So what we will do? We will sit and work on that so that we are not repeating the mistake again. So working on what we have already done. Yes, that is the reflective skills. So that will give you a great confidence and a great experience. So it develops your self-confidence. You will develop your reflective skills, and automatically the engagement also soars up in the class, soars up, which means that increases in the class, that rises up in the class. And the students finally, what they will discover? They will discover that only finishing the problem is not the goal. The moment we give a problem to the students, what will they think? Immediately, few students, they will solve the problem. Ma'am, I've finished, I've done, I've got the answer. So that's what few students, I'm not talking about all the students, few students they say, right? But after making them to observe and think, they will understand just finding out the answer is not the goal, but to find many multiple strategies in order to solve a problem, different entries into the problem. Yes, not only just finding the solution. So now, what are some ways to get the students started? How can we make the students to engage in the class? That is our main aim, right? As a teacher, that is our great responsibility. We should make all the students to participate, right? So how are we going to engage the students effectively? Now, the first thing, now comes here the picture of I notice and wonder. So when we give a problem to the students in the classroom, what they will do? Either if it is a primary students, what they do, either they do addition or subtraction. If it's a middle level student, either they end up with multiplication or division. So whatever pops up in their mind, whatever comes to their mind, just any random operation, they end up with some random operation because they are not confident about what they are doing. Though they have given the right answer, they may not know the way to check whether they have done it right or wrong. So finally, what happens? Finally, they don't understand the story of the problem at all. So this is what happens. Like whenever they get the question paper, just they find it difficult to relate the numbers, in what way they are related, how they are related. They may not understand the representations in the question paper. Just they end up with some random operations, right? So finally, they don't understand the story of the problem at all, right? So what happens next? Repeat it this time. Okay. Now, so why even children, we have seen in the exam hall, while correcting the answer paper, we find even the best performer or whichever the student may be, they would have made some careless mistake, which we cannot tolerate. Oh my God, why the student has done such a mistake, right? We used to feel like that. Why that happens? Like why they end up with some random operation? Why is it happening? Why they do that? Because they are under some pressure. Because they are under some pressure. They have to get good marks. They have to complete within the stipulated time, and they are scared of parents. Yes, so they are under so many pressure, right? They may know one question, they may not know the other question. So they are totally into pressure. So it's our responsibility to give the students a pressure-free environment, stress-free environment. And that we cannot provide that in the examination hall, but we can provide in our classroom, right? So create a safe environment where students focus on sharing their thoughts without any pressure to answer or solve a problem, right? We are the teacher over there, and the peer group, the friends around them, It's a classroom that can give the stress-free environment to them, and it's our responsibility to provide such an environment to the students. Okay, now we are presenting a scenario, a problem to the students. Now we are asking them to notice. So what happens when you give a problem in the classroom? Immediately that creamy level students, immediately they'll raise their hands. Yes, you know that all the students, they will not participate. Yes, few students, they will raise their hands. So don't ignore them. Just take the whatever they have observed, just note down whatever either on the board or you can ask them to write in the classwork. Yes, so observe the notice, they have noticed something and they have given the feedback. Now, don't forget to acknowledge the students, those who have given the answer. You have to acknowledge. Yes, you need not praise them. You need not ask them any question. Oh, great, you have given such a great solution. You are just, no need to praise, because the other students, they will lose the curiosity to find the answer. So then next, ask the students, what do you wonder? Again, same set of students, they may raise the hands and they come out with answer, right? So now you record whatever they have given. Yes, and now you may ask anything that you need clarification. Now comes the part of discussion in the class, right? Okay. Now forget the problem, leave the scenario. That is not our goal. Our goal is to engage the students. We have to make everyone involved in the classroom, right? So now there are two set of students in the classroom. One who thinks, my God, I don't understand anything. Even if I try to solve, I'm not going to get answer for this. That is one set of students. Another set of students, oh, I know everything. I know everything. I can solve within a minute and I can find out the answer. Such set of students, right? These two set of students you can find in the classroom. Yes, as teachers, we all know who can do this, who can do that, right? So sometimes when we put the problem on the board, the students, they notice the question and they turn into these two modes, right? Either I know everything or I don't understand anything, right? So here comes the difficulty to facilitate the whole group of students. Now we are introducing the brainstorming. Like the first student doesn't participate because he don't know anything. The second student, he is also not interested because already he know about that. Okay, so now we have to facilitate all set of students. So you use the concept, I notice, I wonder. Okay, and even now leave the question and now keep the key information that is available in the question also. Again, I'm saying now our goal is to make the students participate in the class. Yes, now bring the problem and explain them in your own better strategy, or explain it as a story in the classroom. Yes, now ask the students not to answer, ask them to question you. Questioning is the best scenario to understand how much the students have understood, how much the concept have reached them. So you know your own set of students, so you know how to deliver the content. So you deliver it in the form of a story, and now you ask the students to question you or the entire group gathered in the class, right? So now once they get into discussion, now few students, they will understand what is supposed to do and what we have to do, and they can predict what the problem exactly says. Yes. Now the third set of students, we don't know whether they know or they don't know, like they remain silent. It's very difficult to guess them because they are shy to participate. Lack of confidence, they will not participate. Let it happen, whatever happens. I'll be like this. They hesitate because they feel shy, because they think what the teacher will think if I ask this question. Will this question turn out into a stupid question, or if my answer turn out to be useless? So thinking that, due to lack of confidence, they will not participate at all. So in this situation, what is our responsibility is we should make accountability of the participation of all the students, right? So this brainstorming helps all the students to participate in the session. Okay, so how we are going to cover all the students and how we are going to engage all the students. What do? Just record all the feedback, whatever they have given. Those students who haven't participated, just ask them whatever that comes to their mind in their classwork or in a sheet of paper. Now we have recorded whatever they have written. It can be anything. It can be meaningless also, but they should have written something, right? So that is our intention. Now, what happens? So they would have spent some time to do notice and observation, right? Those students, I said, who are shy to participate in the class, what we have to do, we have to make them pair up with who's sitting near to them. Pairing, yes, with a friend who's sitting close to them. Make them to write together. Let them share whatever. Let him copy, that doesn't matter. Let him copy from the friend sitting. At least he's writing something, observing something, right? So make pairs among the students and make them to write whatever they have understood. Now ask all the students, allow them to discuss, allow them to whatever they think in their mind, whatever they have observed and whatever they have noticed and whatever they think in their mind. So here comes the healthy discussion among the students, right? And now ask the students to record whatever they have observed apart from what they have noticed. If they have recorded whatever apart from what they have noticed, now you would have received so many solutions, different way, different strategies from the students itself, right? So this way you can make them to think. Let it be anything. It can be valid or invalid, something they would have noticed and they would have observed and they would have wondered, right? So this way you can make everyone to participate in the class, and that is absolutely our responsibility. So in this manner, each student is accountable for noticing and wondering before hearing from others. So when discussion starts, when the inquiry-based learning starts, obviously the thoughts flow in the class. So they share what they have understood in the class by discussing with the peer students. Okay, now you may ask, we have noticed, we have wondered. So what do we have to do next? Yes, noticing and wondering is a very good tool to help the students in order to understand the story. The quantities given in the problem, that is the numbers given in the problem. Now they will be able to relate the numbers. How this number is related to the other number given the problem. And now they will understand what the problem tells and what is expected from the problem. Only when they notice and wonder, only when they observe and think, they will understand what is given in the problem and what is expected from the problem. So now they will have some sort of ideas, not exactly the solution, some sort of idea they would have received so that they can start to solve. Always our goal is the process and not the product. So we should concentrate more on the process. We are not bothered about the solution. Our concentration is on the process and not about the product. Don't bother about the end result. The process should happen over there. So how can we implement this? By some activity for the students. Yes, now here comes one activity. It's for your participation, right? Sheila is going to put tiles on the floor. It looks like a bathroom or it may be a kitchen, whatever it is. So the measurements are given here. Okay. Now you just notice and wonder. Just observe and tell me what you have noticed. I'm not going to give any information about this. Just observe this and tell me what you have noticed. I hope you all are there.
Yeah, ma'am.
One
Yes.
rectangle, one square.
Can see some shape.
Yes, it can be anything that whatever you have observed, you can say.
It is like a plan
closed
of any
kitchen.
room.
Okay. Anything else? Even I've given the measurement. Yes.
Looking like it's a polygon. Then
It's a polygon.
somewhere you wrote sink in the spot. So I was wondering why they leave this much space for sink.
Okay, this is maybe a kitchen or a washroom. So this is the
Anything.
space provided for the sink. Yes, fine. I agree. Totally agree. Why this much space for the sink? Yes.
Like that, the people will give different answers. They
Yes,
won't
yes,
get-
yes, I agree. Whatever, like you're saying, I agree to everything.
And
Anything else that you have observed?
And for finding area, we have to split this to two rectangle, ma'am.
Okay, good.
sides are equal. I can see two of its sides are equal.
Fine. Yes,
And
good.
This is the area cut by one part, 1/3, I think 1/4 or 1/3 cutting.
One part is rectangle, one part is a square.
Okay. I'm taking all the inputs, whatever you're giving. I'm not going to give any feedback on whatever you have said. I'm just taking the inputs. Okay, shall I proceed? Do you observe that
Yes,
all the numbers are multiple of 4?
no, ma'am.
Yes. Yes. Did you
Yes,
notice
ma'am.
that all the numbers are multiples of 4?
Yes,
Yes.
Yes, ma'am.
Yes. And many things, not only that. You may think, yes, why this much space for a sink? Is it a bathtub or a sink? Yes. Okay, fine. That's fine. Many of you were you tried to answer. That doesn't matter. Now, my aim is this is what the same was given to an 8th standard student. I mean, not to a student, to a classroom. This was the feedback, whatever they have observed. This was given by the students. Like, two sides are equal, two sides are 60 inches, one side is 28, they are longest. Some may be relevant, some may be irrelevant, but everything is valid. As I said, the aim is to make everyone to participate. These are the students, those who hesitate to participate in the class. So these many feedbacks that we have got from the students who hesitate to part, not the creamy layer of the students. These students, they have given this feedback. Those who hesitate to, they are shy students, those who don't participate in the class. The long side of the sink is. So this is how we can make the students to think, to observe and think. That is notice and wonder. Now, what is expected from the figure? What is expected? So generally the question will be how many tiles are needed, right? And how many tiles will exactly fit and how many extra tiles we may have to cut and place it over the space which is not filled. So this we can derive little by little if we get the feedback from the students. Finally, we derive at the question. Question, we have to get the question from the students and we shouldn't bother about the answer at all, right? So what do you feel? What should be the size of the tile that we should choose? This is my question to you all. What should be the size of the tile that will fit exactly in this area? A square, it should be a square tile because already it was mentioned in the previous slide. It should be a square. What should be the side of each tile?
4.
4, good. 4 will be
4 into 4.
absolutely right. 4, yes. It should be the side of the tile should be 4, right? Good observation. And yes. It's noisy, ma'am. Someone is not on mute. So as I'm sharing my screen, I couldn't find. Yes. So as we make the students to observe and think and participate, obviously they'll turn into a proficient students, right? Now they will understand the problem, analyze the story, and they'll make out the relationship between the numbers that is given in the question, right? So even they may not end up with the right answer, but they will guess. So what is expected from the question? What is the meaning of the question, right? So we can give them a pathway to think and not just directly end up with some random operation, right? We can show them a path, how to think, what to think, how to think, and what they can observe. Yes, not just directly giving out some random solution. Now, the question is, you have decided to paint your room. So your room has 300 square feet of wall space to paint. Okay, so who's anybody rhyming with Sam in this class? Okay, someone called Ramya is there. So I'll write Ramya here. Ma'am, do you mind if I use your name?
No, ma'am. Kids will be very happy. If they use their name, they will be very excited.
Okay.
I'm so excited.
Instead of using some random name, person name, I'll use Ramya. Okay, fine. So now Ramya says it took her 10 minutes to paint 25 square feet. At this rate, how many hours will it take Ramya to paint your room? Now, just have a look at the problem. Notice it. Observe it. I'm not in the presentation mode, right? Okay. So I find see a final answer. I don't want the final answer. Just I want to notice and I want you people to observe and think. What are the different ways? What are the different entry points into this problem? Okay, first, any suggestions? You can use unitary method.
Ma'am,
Yes.
25 square.
Yes, ma'am.
ma'am, we can in 300 square feet we can find how many 25 square feet. We can divide 300 by 25.
Yes, good, ma'am. Exactly. Yes.
For 10 minutes,
Then we
if I'm
multiply
painting for 10 minutes, for 1 minute, how many square feet I gonna paint?
120
Like
minutes, ma'am, totally.
Yes, you can unitary. That is for 25 square feet, 10 minutes. For 1 square feet, how many minutes? Then for 300 square feet, 10 minutes. So there are where entry points are many, like how to enter into the point, how to relate the numbers given in the problem. So when we enter into the discussion part, when we enter in the question session, obviously we will get many number of solutions to a problem. Now I'll post this in the WhatsApp group. This is the assignment. If you want, you can take a snapshot or I'll post it in the WhatsApp group later. This is the assignment which you have to do. Okay. Now this is another a case study. This was given to our students. This is a case study. Like just observe this. And what sort of questions that you can pose? I don't want any answer. What are the questions that we can ask from this case study? Possible questions from this case study.
How many shapes
how many
here?
rectangles we are having in this image?
Okay, fine. Yes, ma'am.
In the area of the shaded part.
Yes, good. Yes, ma'am.
Area of the window in algebraic expression form.
Yes, yes, ma'am.
Area of the door.
Area of
Find
the
X.
door, good. Area of the door. Anything else? Yes, fine. Now, few possible.
Area
not
of
all-
wall.
Area of
Area
the
of wall except area of wall except window and door.
Yes, good, excellent. So we can pose many questions based on this case study. Just I will share few questions based on this case study. See, what is the area of the window? Exactly whatever you teachers have said. What is the area of the wall? What is the required part of the wall to be painted? Yes, that was shared by sir. And if the value of x is replaced by 3, then find the area of the door. A few questions that I have shared, but we can ask many questions from the given case study. Now, okay, totally we are into theory part. Now let us again activate our mind. Though your mind is active, like try to answer this question. Two girls were born to the same mother at the same time on the same day, the same month and the same year, yet they are not twins. How? Why? These two questions are very important related to mathematics, right? How? Why? Why are they not twins? Any answers?
Excuse me, ma'am.
Yes, ma'am.
Maybe there is a triples and
Yes, absolutely. You're right. They are triplets. One more girl
yes,
is also
ma'am.
not only two girls. There
Yes.
are triplets born. So they
Yes,
are
ma'am.
triplets. That's why they are not twins. You're right.
Yes, ma'am.
Okay. The day before yesterday, I was 25. The next year, I'll be 28. Is that really possible? Yes, it is possible. How is it possible? Then what should be my birth date? It's possible only on one day in a year.
December
Which day is
31st.
it? December 31st. Absolutely right. Yes.
Okay.
Now, how to get a number 100 by using 4 sevens and 1 1. Only 1 1 and 4 sevens. Any guess?
We can add or subtract, we can do anything, or
Any operation, not only addition, can be any operation.
I think 77 minus 1. I mean, we have
77? Yeah, tell
plus
me.
7 plus 7 minus 1, I think so.
77?
It won't come. No.
No issues, but just it's just try. That's it.
Excuse me, ma'am.
Yes, ma'am.
7 7 product and another one more 7 7 product. Okay, sorry. Then two I must add two more. No. Okay.
Okay. Any guesses?
7 7.
Okay. In the meantime, I'll, okay, y'all are working out, so I don't want to distract. Okay, shall I come out with the answer? Shall I? There are a few solutions even I'm not sure about. Just I got only one answer that if you give permission, I'll share it.
Yes, ma'am.
Yes.
Yeah, ma'am.
Yes,
Yes.
ma'am.
It's 177 minus 77, right?
100?
177
Yes, ma'am.
minus 77, it will give you 100, right?
Absolutely, ma'am.
Yes.
Absolutely. We agree, ma'am.
Okay. Now I'm not going to share the next screen. Before that, just I just share a joke with you all, because next is going to be the again few more theoretical part. So a father is asking to his son, why did you get very less score in the science exam. Why? What happened? Why your score is so less? So this son replied, because of absence. So why you didn't miss the science exam? Were you absent for the exam? Yes. No, no. The one who's sitting next to me was absent. I hope you all have understood the joke.
Yes, ma'am.
Okay. Okay, fine. Then one more. This father is asking to his son, why is your mother today seems to be so silent? Why is she sitting very silently in the, I mean, what happened? So the son said, nothing, dad, nothing. I just did a mistake. She asked for the lipstick. I gave her Fevistick. Okay. And the highlight is the father said, God bless you, my dear son. Okay, fine. Now, this I'll share it at last. Okay. So now comes the effective teaching practices. Okay. Again, we have to focus now. Establish. Sorry. Okay. So these are the 8 steps by which we can, like mathematics can. These are the 8 practices for the effective mathematics teaching. So what are the key words in these 8 processes? The goal, the task, the mathematical representation, discussion, the questions, the fluency, the understanding, the struggle, and the use of the evidence, right? What are these keywords? Let us get into the discussion. So establish mathematics goal to focus learning. So the goal should clearly state what the students are supposed to learn. Okay, what is the learning outcome? Finally, what have they understood the concept or not? That is the learning outcome. Be firm with the learning progressions of the concept. What do you mean by learning progression? Learning progression means the sequence of teaching, the steps that we undergo while teaching. The learning, finally, how we get the expectation. So we should be firm with the teaching progression. That is the sequence of teaching. And the goal should focus on what the students will do rather than, that is already I told you several times, that is the process is important and not the end product. What they will learn as a result of engaging in a particular activity. Yes. So just for example, I've shared this. These are when we give a scenario, these are the different understanding by 3 different students. That is 1 by 3 divided by 4. So they may think, how can we divide 1 by 3 by, it's a fraction, it's a whole number. How can we divide the smaller by a bigger number? So how the students think in a different way, right? But the student should think. That is our main goal. 4 divided by 3. Then another student may think 4 divided by 1 by 3. 1 by 3 divided they are one. It's look like same. They are one at the same. How they are different and how can we get different quotient? Yes. What does another student, they can do 4 divided by 1 by 3. Immediately he'll do that. Okay, change the sign. Write the reciprocal of 1 by 3 and we'll get 12. So different levels of understanding by different students. So what we have to do is implement, next step is implement tasks that promote reasoning and problem solving. Reasoning skills are, what does that reasoning skill means? That converts the complicated things into logical thinking. Reasoning ability is the cognitive skill, that is, we know the 3 main skills, that is psychomotor, cognitive, and the emotional skills. The mathematics is mainly targets the cognitive skills, that is the thinking ability, the reasoning ability, the problem solving skills. So what Albert Einstein says that if I had an hour to solve a problem, I will spend not only 55 minutes just by thinking about the problem and just 5 minutes thinking about the solution. If you get into the thinking process, obviously you'll end up with the solution. So the thinking process is most important. So explore the task should allow students to explore mathematical ideas or use of the procedure. What do you mean by procedure? Procedures are that is the steps in solving the problem. The sequence of the mathematical operation is called the procedures. Okay, that we carry out in order, right? Which operation should follow next, which should come first, which should come next. Okay, that is possible only when we understand the concept. And next is that builds the student current understanding, what they've already learned and what they've understood now. Have multiple entry points, like as we discussed in that paint problem, how the different way of solving a problem. Not only one method, different methods of entering into the problem. Allow for varied solution strategies. Many strategies can be followed in order to attain the learning outcome. First, we have to sense what is given, sense the data, interpret the data, collect the given information, organize it, then find the solution. Once we find the solution, our process is not over. What conclusion are we arriving at? Then comes the application where we can apply in the future. Representation matters a lot. Representation. What do you mean by representation? Mathematical representation. Examples like the number line. When we teach integers, we use number lines, right? And pie chart, graph. All these are mathematical representations. So these representations are to be introduced. It has to be discussed and it should be related to the problem, how it is connected to the problem. How can we use these representation in order to deliver the content? And it focuses on the student's attention. Then it supports the student's ability. This representation, it supports the student's ability to justify and explain the reasoning. Next, facilitate meaningful mathematical discussion. As I said, questioning is a very important part in learning mathematics, right? So we should honor every student's thinking. Let it be valid or it may be irrelevant, but it should be valid. We should honor the student's thinking, right? And that helps in sharing the ideas, clarifying whatever they have understood. When they get into the discussion, they can clarify the understanding. One, they can understand in a different way and another. So it will get clarified and that develops a healthy argument. That develops a convincing argument. Now that will help the students in analyzing and that helps in comparing whatever the reasons given by all the students that can be analyzed and compared. So this helps in advancing the math learning. That will take them to a different level. Pose purposeful questions. Yes, only the questions. If we ask the students to ask questions, that will give us the feedback, what the students have understood. What is the level of understanding? How much they have understood? Whether they have understood the concept correctly or they have misunderstood the concept correctly, we can understand only when they ask the question. Okay, rather we asking the questions, it's always better if the students ask the questions. So always encourage students the purposeful questions, always encourage the students to explain, elaborate and clarify their thinking. And make the ideas, that will make the ideas accessible for the students for discussion. Accessible means easily reachable. Next build the procedural fluency. What do you mean by procedural fluency? As I said, it's a sequence of the mathematical operation. How is it possible? Only from the conceptual understanding. Only if the concept we have understood, then we can build the procedural fluency can be built. Once we build the procedural fluency, automatically your computational fluency or the skills will increase. So the knowledge, skills, real world situation, all are interconnected with the concept. So that the procedural fluency, that is the sequence of the operation, what it gives, that is, it builds the foundation of the conceptual understanding, right? And that may not happen within a day or two. So it takes some time because concept should be deep rooted. You should have a deep understanding on the concept. So that will turn into generalized method for solving any problem. Even we need not use the formula. Once you understand the problem, once the concept is clear, you can generalize a way of solving the problem. So that will enable the students to choose the method to solve the contextual and the mathematical problem. Contextual problem means problems that are related to the real life problem and the mathematical problem. So conceptual understanding is nothing but making sense of mathematics. Procedural means doing the math. Problem solving application is the use of mathematics. Now, we should allow the students to struggle. So when they are into the process, the student, they should struggle. We should give them the opportunity to struggle. Only if they struggle, they can understand the concept. So they should come out of the comfort zone, and we should facilitate the students in order that it should be happily they should struggle. Struggling means not like crying and studying or writing imposition, writing the formula 10 times, not like that. They should try to understand the problem. That is struggling. So we should develop that. So they can get frustrated, distracted, challenged. So how we are making the student to struggle and understand the concept. So productive struggling should considered essential to learning mathematics, and yes, it should happen. Struggling should happen, right? That develops the students' capacity to face the challenge. Once they struggle only, they can understand the concept. Yes, so help students realize that they can do well in mathematics in using appropriate strategy. Kindly mute. Yes, now comes evaluation and the use evidence of students' thinking. What is that evaluation and evidence? What does it mean? Evaluation and use the evidence of students. Nothing but what is that evidence? That is the different way of testing the evidence that provides a window to students' thinking. That helps the student to determine the level of understanding the students, right? Yes, of course, we have to conduct test. Only then we can understand the level of the students' understanding in order to reach the goals, right? So be used to make instructional decision. What does it mean, instructional decision? The instructions that we deliver the students. Generally in the in our school days, what the teachers used to say, don't read louder, read by heart. Now there is a separate session for the students to read out louder. So the instructions should change according to the situation or according to the students. So whatever we follow, that the same cannot be followed now. So it should change according to the trend, according to the students' interest, according to the environment. It for different lessons also. So these are the benefits. So when students solve the problems, when they get into exploring the mathematics according to the context, not absolutely as an abstract. We know mathematics is abstract, right? They will feel when they think and when they observe and think, they will not have the feeling, that abstract feeling of mathematics, they will not have, right? Please stay on mute. Yes. So that develops the confidence in the student. So they feel that they have the ability to think and solve the problem. Then discussions, as I said, it's a very rich source of information about students' mathematical knowledge and understanding. So encouraging discussion, then problem solving activities. As I said, it gives varied entry points to get into a problem and think about the problem and to work on the problem. So problem solving skills also get developed, and it gives students the tool to apply their mathematical knowledge to solve the hypothetical and the real life problems. So with this, I end my session. And okay, it's not at over, just one more thing. So this is how, am I sharing something?
Yes, ma'am.
So this is just I've taken example of a lesson which I taught for 7th standard students. Actually, I prepared this PowerPoint, but unfortunately, as this lesson was omitted because of the online classes, so I thought let me use this PowerPoint presentation for our class. Okay. So now it's time for you to observe. What do you notice? What is this? Okay, I'll do the slideshow. Do you observe anything on the screen?
Identical twins, ma'am.
What, ma'am? They are twins. Yes, we call them twins because they look similar, right?
Yes,
How these cats look?
Similar.
Similar, right? So this is the time for the students to observe. The apples are
Looking similar.
similar, right? Now, how about the shapes? Aren't they similar?
Yeah, ma'am. They are similar.
They are similar, right? Now,
Yes, ma'am.
think about these shapes. They are similar, right? Again. Now, how do you say that this is different from the previous cat picture, the previous picture I showed, right?
They are similar, not equal. Now they are similar and equal itself.
Yes,
They are
yes,
like
good. Now look at these shapes. They are not only similar, but same in size and shape. As teachers, now you could have guessed what lesson it's going to be.
congruent.
Yes,
Confident.
the student, I was making them to observe whatever I'm sharing. Okay. So this is an example that which you having same size and shape that you see daily. Now, what is a term that have the same size and shape? That is congruent. So by making them observe the notice, now I introduce the concept of congruency. So this is then about how it, like the symbol of congruency. Then example. So this we related to an example. The shape of a triangle. Now they'll have this is the visual representation. I was talking about representation, right? If they see visually, they'll have a better understanding. So 3 sides, 3 angles. Are your hands are congruent? Now I'm relating to the real life. There we can find congruence. Are your hands are congruent?
Yes,
Have exactly the same shape and size are known as congruent figures. Yeah, now if you hold it like this, you can see they are congruent figures, right?
Yes, ma'am.
So what is congruency? I'm not explaining much. We're running short of time. Okay.
3 circle concurrence.
Yes. Though they change in, I mean that though they change the position, but still they are congruent, right? The position doesn't matter for congruency. Now, which of the following are congruent? A and B are congruent, then E and G are congruent, other figures are not congruent. Again, which shapes are congruent? Now, they'll have better clarity.
Heart and
We have to click on it. Yes.
Okay, ma'am.
Congruent. Anything else? This is congruent. Anything else?
Heart is
Star.
Art is congruent. Then
orange color flag like that. The piece
we'll
of
check
paper.
whether what happens if I click the star. They are not congruent. This is congruent.
Semicircle.
Is this congruent? Not. Not. Are they congruent? Yes. So when if I share this, they'll have a better clarity or about congruency, right? Now, if we show the difference, similarity, what is similar and what is congruent. Now coming into the shape, that is the triangle which we are going to discuss about. So just I said, the shape may be a reflection of each other, or it can be rotated or translated. That doesn't matter. Congruent is, if they are congruent, whatever position it may be, they will be congruent. Now, in order to test their understanding, I will ask these questions. Suppose two triangles have the same side length. Do the triangles have to be congruent? Yes, because all the angles are determined by the side. So they are congruent. Now, would the same be true if we talk about quadrilaterals? Any answers?
What's the question, ma'am? The quadrilateral. For
Same
quadrilateral.
be true if two quadrilaterals have the same length. Can you say any two quadrilaterals that have all the four sides same? A rhombus and a
No.
square, right? No. No. Yes, a square and a rhombus can have the same side length but not different shapes, right? Okay, now I'll introduce an activity for the students. Okay. Now, if I introduce this activity, now I'll make the students to involve in that process of understanding. That will give a very clear picture of the concept of congruency. Now this I'll give it as an assignment for them in order to construct a triangle with the, just not triangle, not construction. Okay. Please, ma'am, audio is turned on.
Egg puff করলে samosa. ওরে করেন। কিছু পাতিয়ে reels है.
Brinda ma'am, kindly can you mute yourself?
Yes. I'll just run the slides. So step by step, that is the sequence I said, how the strategies, that activity, how it can be introduced step by step, and thinking, wondering, all the process are involved. So like this, we can introduce a lesson so that the concept reaches the student easily. So I'll go for a recap of whatever we have discussed. And with that, I'll end the session.